Hello everyone, and welcome to this video short where we're going to discuss flow networks. Now, as we've seen in previous modules and previous video shorts, we can model data and model problems using graphs. In many of these problem scenarios or in data sets, we are interested in analyzing or assessing the flow within the network. And depending on what the network is being used to model, flow might have different meanings. So let's take a look at some examples. Now, intuitively, a scenario where we might use a graph to model data or to model some problem scenario is for network analysis, whether we have a road network or a social network or a computer network. And so in this particular example here, we have again, a transportation network for railways. And so the nodes might represent railroad stations and the edges might represent tracks. And so in this particular scenario, we might be very interested in analyzing the flow. So this would be the flow of traffic, the flow of persons like along this network. And so you could do traffic analysis, transportation analysis, you could do logistics, pipeline analysis, all sorts of things, all sorts of analyses to be done with respect to the flow on a network like this. And the same might be true in a social network where flow might not represent, let's say, cars on a roadway or trains on a railway, but might represent communication or rumor spreading. Or if we had a model or a graph that was modeling a computer network, flow might represent the passing on or the transport of data through the network. And so again, some very clear applications for analyzing the flow on a network. And in many of these instances, we might be interested in identifying the maximum flow on a network. And so this is a type of flow of particular interest, as we'll see here in just a moment. But first, let's take a look at a network and define some key keywords and look at the vocabulary and look at some key concepts. So given a graph here, like this one in this example here, generally speaking, when we're analyzing a flow, we will have a source for the flow and a sink. Right? This is not necessarily always the case. Sometimes they are also added just as in addition to an existing network to help with the analysis. So within a flow network, it's a good idea to identify and define the source node and a sink node. Within flow analysis, we also assign attributes to the edges called capacities, and this limits the amount of flow. It is a maximum number for the amount of flow that can travel along an edge within a flow network. Other attributes can be added to edges as well, especially if we're doing some other type of analysis other than flow, such as a min cost flow, right? We might also have costs or penalties associated with each of the edges, but generally speaking, we at least have a capacity associated with each edge as well. So a maximum flow is simply if we have a source and a sink, and flow is emanating from the source and traveling through the sink, through this network where we have constraints associated with the amount of flow that can travel on each edge. What is the maximum amount of flow that we can get from the source to the sink, given the structural constraints and the capacity constraints of the network? Right, and so there are multiple flows that can occur within a network. And so given a brute force approach, we could just simply look at all the possible flows. Or we can come up with some sort of algorithm that can give us the best flow or the max flow or the min cost max flow, or again, depending on what problem we're trying to solve, which flow we're interested in. So the assignment of values to these edges or flows to these edges are referred to as a flow. And so here's an example of one flow on this network here. So here, the capacities are shown in green, the flow is shown in red. And so here, this indicates that from our sink, we have a flow of 1 traveling along this edge and a flow of 2 traveling along this edge. And then we have a flow of 1 going up here, a flow of 1 going over here. Note that all the flows are less than or equal to the capacities. And so in this particular network here, our total inflow and outflow, right? The inflow coming from the sink is 3, and inflow coming from the source is 3. And then the outflow arriving at the sink is also 3. So the total flow in this particular example is 3. And we can see how that flow propagates through the network here in this illustration. All right, as previously noted, in many instances, we're interested in the maximum flow. So we might ask ourselves, is this the maximum flow possible on this network? And so what we could do is just go through all possible combinations and identify which flow is maximum, right? Investigating all possible flows given this network. And if we were to do so, we would find that one of these flows might be better than the other. This one is one that is a maximum flow, meaning that is will give us the maximum total flow in our network, which is 4 in this particular network. And so this is one of the max flows here where we would have 2 going from node here to traveling along this edge here, and so on and so forth, and we would get 2 out as well. I encourage you to try by investigation, try by example to see if you can get any more flow through this network. Right? I think you will find that this is the maximum allowable on this network. And so, again, there are a number of interesting algorithms that employ greedy strategies or other strategies to find this maximum flow. I encourage you to investigate the examples in this slide deck to identify the pros and the cons associated with each of these algorithms, as many problems that exist in data science, especially those that we might frame within a graph model, right, have to do with analysis of flows and or finding maximum flows. And so these are not just limited as well to these sorts of problems where we might have a road network or a social network, but we can, in general, map many problem sets to a graph and solve them using a flow problem. More to come on that when we talk about reductions. All right, thank you for joining me in this video short, and I will see you in the next episode.